sleep in midlife and old age. As you, the reader, may painfully know, sleep is more problematic and disordered in older adults. The effects of certain medications more commonly taken by older adults, together with coexisting medical conditions, result in older adults being less able, on average, to obtain as much sleep or as restorative sleep as young adults. That older adults simply need less sleep is a myth. Older adults appear to need just as much sleep as they do in midlife, but are simply less able to generate that still necessary sleep. Affirming this, large surveys demonstrate that despite getting less sleep, older adults reported needing and indeed trying to obtain just as much sleep as younger adults. There are additional scientific findings supporting the fact that older adults still need a full night of sleep, just like young adults, and I will address those shortly. Before I do, let me first explain the core impairments of sleep that occur with aging, and why those findings help falsify the argument that older adults don't need to sleep as much. The three key changes are: 1. Reduced quantity quality, 2. Reduced sleep efficiency, and 3. Disrupted timing of sleep. The post-adolescent stabilization of deep REM sleep in your early 20s does not remain very stable for very long. Sooner than you may imagine or wish comes a great sleep recession, with deep sleep being hit especially hard in contrast to REM sleep, which remains largely stable in midlife. The decline of deep and REM sleep is already underway by your late 20s and early 30s. As you enter your fourth decade of life, there is a palpable reduction in the electrical quantity and quality of that deep and REM sleep. You obtain fewer hours of deep sleep, and those deep and REM brain waves become smaller, less powerful, and fewer in number. Passing into your mid and late 40s, age will have stripped you of 60 to 70% of the deep sleep you were enjoying as a young teenager. By the time you reach 70 years old, you will have lost 80 to 90% of your youthful deep sleep. Certainly, when we sleep at night and even when we wake in the morning, most of us do not have a good sense of our electrical sleep quality. Frequently, this means that many seniors progress through their later years not fully realizing how degraded their deep sleep quantity and quality have become. This is an important point. It means that elderly individuals fail to connect their deterioration in health with their deterioration in sleep, despite causal links between the two having been known to scientists for many decades. Seniors therefore complain about and seek treatment for their health issues when visiting their GP, but rarely ask for help with their equally problematic sleep issues. As a result, GPs are rarely motivated to address the problematic sleep in addition to the problematic health concerns of the older adults. To be clear, not all medical problems of aging are attributable to poor sleep, but far more of our age-related physical and mental health ailments are related to sleep impairments than either we or many doctors truly realize or treat seriously. Once again, I urge an elderly individual who may be concerned about their sleep not to seek a sleeping pill prescription. Instead, I recommend you first explore the effectiveness and scientifically proven non-pharmacological interventions that a doctor who is board certified in sleep medicine can provide. The second hallmark of altered sleep as we age, and one that older adults are more conscious of, is fragmentation. The older we get, the more frequently we wake up throughout the night. There are many causes, including interacting medications and the diseases, but chief among them is a weakened bladder. Older adults therefore visit the bathroom more frequently at night. Reducing fluid intake in the mid and late evening can help, but it is not a cure-all. Due to sleep fragmentation, older individuals will suffer a reduction in sleep efficiency, defined as the percent of time you were asleep while in bed. If you spent 8 hours in bed and slept for all 8 of those hours, your sleep efficiency would be 100%. If you slept just 4 of those 8 hours, your sleep efficiency would be 50%. As healthy teenagers, we enjoyed a sleep efficiency of about 95%. As a reference, I'm sure most sleep doctors consider good quality sleep to involve a sleep efficiency of 90% or both. By the time we reach our 80s, sleep efficiency has often dropped below 70 or 80%. 70 to 80% may sound reasonable until you realize that within an 8-hour period in bed, it means you will spend as much as 1 to 1.5 hours awake. Inefficient sleep is no small thing. As studies assessing tens of thousands of older adults show, even when controlled for factors such as body mass index, gender, race, history of smoking, frequency of exercise, and medications, the lower an older individual's sleep efficiency score, the higher their mortality risk, the worse their physical health, the more likely they are to suffer from depression, the less energy they report, and the lower their cognitive function, typified by forgetfulness. Any individual, no matter what age, will exhibit physical ailments, mental health instability, reduced alertness, and impaired memory if their sleep is chronically disrupted. The problem in aging is that family members observe these daytime features in older relatives and jump to a diagnosis of dementia, overlooking the possibility that bad sleep is an equally likely cause. Not all old adults with sleep issues have dementia, but I will describe evidence in Chapter 7 that clearly shows how and why sleep disruption is a causal factor contributing to dementia in mid and later life. A more immediate, though equally dangerous, consequence of fragmented sleep in the elderly warrants brief discussion. The nighttime bathroom visits and associated risk of falls and thus fractures. We are often groggy when we wake up during the night, and due this cognitive haze the fact that it is dark. Furthermore, having been recamped in bed means that when you stand and start moving, blood can race from your head, encouraged by gravity down toward your legs. You feel lightheaded and unsteady on your feet as a consequence. The latter is especially true in older adults whose control of blood pressure is itself often impaired. All of these issues mean that an older individual is at a far higher risk of stumbling, falling, and breaking bones during nighttime visits to the bathroom. Falls and fractures markedly increase morbidity and significantly hasten the end of life of an older adult. In the footnotes, I offer a list of tips for safer nighttime sleep in the elderly. The third sleep change with advanced age is that of circadian timing. In sharp contrast to adolescents, seniors commonly experience a regression in sleep timing, leading to earlier and earlier bedtimes. The cause is an earlier evening release and peak of melatonin as we get older, instructing an earlier start time for sleep. Restaurants in retirement communities have long known of this age-related shift in bedtime preference, epitomized and accommodated by the early bird special. Changes in circadian rhythms with advancing age may appear harmless, but they can be the cause of numerous sleep and wake problems in the elderly. Older adults often want to stay awake later into the evenings so that they can go to the theater or the movies, socialize, read, or watch television. But in doing so, they find themselves waking up on the couch, in a movie theater seat, or in a reclining chair, having inadvertently fallen asleep mid-evening. Their regressed circadian rhythm, instructed by an earlier release of melatonin, left them no choice. But what seems like an innocent dose has a damaging consequence. The early evening snooze will jettison precious sleep pressure, clearing away the sleepiness power of adenosine that had been steadily building throughout the day. Several hours later, when that older individual gets into bed and tries to fall asleep, they may not have enough sleep pressure to fall asleep quickly or stay asleep as easily. An erroneous conclusion follows. I have insomnia. Instead, dozing off in the evening, which most older adults do not realize is classified as napping, can be the source of sleep difficulty, not true insomnia. A compounding problem arrives in the morning. Despite having had trouble falling asleep that night and already running a sleep debt, the circadian rhythm, which, as you'll remember from Chapter 2, operates independently of the sleep pressure system, will start to rise around 4 or 5 a.m. in many elderly individuals, enacting its classic earlier schedule in seniors. Older adults are therefore prone to wake up early in the morning as the alerting drumbeat of the circadian rhythm grows louder, and corresponding hopes of returning back to sleep diminish in tandem. Making matters worse, the strength of the circadian rhythm and amount of nighttime melatonin released also decrease the older we get. Add these things up, and a self-perpetuation cycle ensues wherein many seniors are battling a sleep debt, trying to stay awake later in the evening, inadvertently dozing off earlier, finding it hard to fall or stay asleep at night, only to be woken up earlier than they wish because of a regressed circadian rhythm. There are methods that can help push the circadian rhythm in older adults somewhat later and also strengthen the rhythm. Here again, they are not a complete or perfect solution, I'm sad to say. Later chapters will describe the damaging influence of artificial light on the circadian 24-hour rhythm, bright light at night. Evening light suppresses the normal rise in melatonin, pushing an average adult's sleep onset time into the early morning hours, preventing sleep at a reasonable hour. However, the same sleep delaying effect can be put to good use in older adults if timed correctly. Having woken up early, many older adults are physically active during the morning hours and therefore obtain much of their bright light exposure in the first half of the day. This is not optimal as it reinforces the early to rise, early to decline cycle of the 24-hour internal clock. Instead, older adults who want to shift their bedtimes to a later hour should get bright light exposure in the late afternoon hours. I am not, however, suggesting that older adults stop exercising in the morning. Exercise can help solidify good sleep, especially in the elderly. Instead, I advise two modifications for seniors. First, wear sunglasses during morning exercise outdoors. This will reduce the influence of morning light being sent to your suprachiasmatic clock that would otherwise keep you on an early to rise schedule. Second, go back outside in the late afternoon for sunlight exposure, but this time do not wear sunglasses. Make sure to wear sun protection of some sort, such as a hat, but leave the sunglasses at home. Plentiful later afternoon daylight will help delay the evening release of melatonin, helping push the timing of sleep to a later hour. Older adults may also wish to consult with their doctor about taking melatonin in the evening. Unlike young or middle-aged adults, where melatonin has not proved efficacious for helping sleep beyond the circumstance of jet lag, prescription melatonin has been shown to help boost the otherwise blunted circadian and associated melatonin rhythm in the elderly, reducing the time taken to fall asleep and improving self-reported sleep quality and morning alertness. The change in circadian rhythm as we get older, together with more frequent trips to the bathroom, help to explain two of the three key time issues in the elderly: early sleep onset, offset, and sleep fragmentation. They do not, however, explain the first key change in sleep with advancing age: the loss of deep sleep quantity and quality. Although scientists have known about the pernicious loss of deep sleep with advancing age for many decades, the cause has remained elusive. What it is about the aging process that so thoroughly robs the brain of this essential state of slumber. Beyond scientific curiosity, it is also a pressing clinical issue for the elderly, considering the importance of deep sleep for learning and memory, not to mention all branches of bodily health, from cardiovascular and respiratory to metabolic energy balance and immune function. Working with an incredibly gifted team of young researchers, I set out to try and answer this question several years ago. I wondered whether the cause of this sleep decline was to be found in the intricate pattern of structural brain deterioration that occurs as we age. You will recall from Chapter 3 that the powerful brainwaves of deep and REM sleep are generated in the middle frontal regions of the brain, several inches above the bridge of your nose. We already knew that as individuals get older, their brains do not deteriorate uniformly. Instead, some parts of the brain start losing neurons much earlier and far faster than other parts of the brain, a process called atrophy. After performing hundreds of brain scans and amassing almost 1,000 hours of overnight sleep recordings, we discovered a clear answer unfolding in a three-part story. First, the areas of the brain that suffer the most dramatic deterioration with aging are unfortunately the very same deep sleep generating regions, the middle frontal region seated above the bridge of the nose. When we overlaid the map of brain degeneration hotspots in the elderly on the brain map that highlighted the deep sleep generating regions in young adults, there was a near perfect match. Second, and unsurprisingly, older adults suffered a 70% loss of deep sleep compared with matched young individuals. Third, and most critical, we discovered that these changes were not independent, but instead significantly connected with one another. The more severe the deterioration that an older adult suffers within this specific midfrontal region of the brain, the more dramatic their loss of deep and REM sleep. It was a saddening confirmation of my theory. The parts of our brain that ignites healthy deep sleep at night are the very same areas that degenerate or atrophy earliest and most severely as we age. In the years leading up to these investigations, my research team and several others around the world had demonstrated how critical deep sleep was for cementing new memories and retraining new facts in young adults. Knowing this, we had included a twist to our experiment in older adults. Several hours before going to sleep, all of these seniors learned a list of new facts, word associations, quickly followed by an immediate memory test to see how much information they had retained. The next morning, following the night of sleep recording, we tested them a second time. We could therefore determine the amount of memory savings that had occurred for any one individual across the night of sleep. The older adults forget far more of the facts by the following morning than the young adults, a difference of almost 50%. Furthermore, those older adults with the greatest loss of deep sleep showed the most catastrophic overnight forgetting. Poor memory and poor sleep in old age are therefore not coincidental, but rather significantly interrelated. The findings helped us shed new light on the forgetfulness that is all too common in the elderly, such as difficulty remembering people's names or memorizing upcoming hospital appointments. It is important to note that the extent of brain deterioration in older adults explained 60% of their inability to generate deep sleep. This was a helpful finding, but the most important lesson to be gleaned from this discovery for me was that 40% of the explanation for the loss of deep sleep in the elderly remained unaccounted for by our discovery. We are now hard at work trying to discover what that is. Recently, we identified one factor, a sticky, toxic protein that builds up in the brain called beta amyloid, that is key cause of Alzheimer's disease, a discovery discussed in the next several chapters. More generally, these and similar studies have confirmed that poor sleep is one of the most underappreciated factors contributing to cognitive and medical ill health in the elderly, including issues of diabetes, depression, chronic pain, stroke, cardiovascular disease, and Alzheimer's disease. An urgent need therefore exists for us to develop new methods that restore some quality of deep, stable sleep in the elderly. One promising example that we have been developing involves brain stimulation methods, including controlled electrical stimulation pulsed into the brain at night. Like a supporting choir to a flagging lead vocalist, our goal is to electrically simulate in time with the ailing brainwaves of older adults, amplifying the quality of their deep brainwaves and salvaging the health and memory promoting benefits of sleep. Our early results look cautiously promising, though much more work is required. With the replication, our findings can further debunk the long-held belief that we touched on earlier. Older adults need less sleep. This myth has stemmed from certain observations that, to some scientists, suggest that an 80-year-old, say, simply needs less sleep than a 50-year-old. Their arguments are as follows. First, if you deprive older adults of sleep, they do not show as dramatic an impairment in performance on a basic response time task as a younger adult. Therefore, older adults must need sleep less than younger adults. Second, older adults generate less sleep than young adults, so by inference, older adults must simply need sleep less. Third, older adults do not show as strong a sleep rebound after a night of deprivation compared with young adults. The conclusion was that seniors therefore have less need for sleep if they have less of a recovery rebound. There are, however, alternative explanations. Using performance as a measure of sleep need is perilous in older adults, since older adults are already impaired in their reaction sleep times to begin with. Said unkindly, older adults don't have much further to fall in terms of getting worse, sometimes called a floor effect, making it difficult to estimate the real performance impact of sleep deprivation. Next, just because an older individual obtains less sleep or does not obtain as much recovery sleep after sleep deprivation does not necessarily mean that their need for sleep is less. It may just as easily indicate that they cannot physiologically generate the sleep they still nevertheless need. Take the alternative example of bone density, which is lower in older compared with younger adults. We do not assume that older individuals need weaker bones just because they have reduced bone density, nor do we believe that older adults have bones that are weaker simply because they don't recover bone density and heal as quickly as young adults after suffering a fracture or a break. Instead, we realize that their bones, like the centers of the brain that produce sleep, deteriorate with age, and we accept this degeneration as the cause of numerous health issues. We consequently provide dietary supplements, physical therapy, and medication to try to offset bone deficiency. I believe we should recognize and treat sleep impairments in the elderly with a similar regard and compassion, recognizing that they do, in fact, need just as much sleep as other adults. Finally, the preliminary results of our brain simulation studies suggest that older adults may in fact need more sleep than they themselves can naturally generate, since they benefit from an improvement in sleep quality, albeit through artificial means. If older individuals did not need more deep sleep, then they should already be satisfied and not benefit from receiving more artificially in this case. Yet they do benefit from having their sleep enhanced or perhaps worded correctly restored. That is, older adults, and especially those with different forms of dementia, appear to suffer an unmet sleep need, which demands new treatment options, a topic that we shall soon return to.